Well, it's another day, it's another Kangoo. Hopefully you can hear me. It's a little bit windy, it's rainy, it's terrible. But thank you to Lucy and Christine from Richmond Aid who've sent me this little Kangoo. So this, now I'm just going to get in because it's absolutely miserable. And yeah, if you're not subscribed, please do so. That would be great. Right, so this fan, so it wouldn't charge. You'll notice it is charging now. We're not out of the woods, but we'll get to that. So this van wouldn't charge. They don't do a lot of miles. This is really low mileage van. It's up 9,000 and something, 2018. Also previously had probably a traction battery repair. Okay, so just park that for a second. So the van wouldn't charge, went to Renault. They sent me a copy of the Renault report, which they didn't. Basically, Renault just pulled the codes and said it's got a battery code. And it's not worth investigating, is basically what they said. It's going to cost too much, just scrap it, which I think is a bit insane. So this is a London charity. They just use it for running around locally, I'm guessing, because of the low mileage. And yeah, so it doesn't really get fully kind of charged and discharged, fully cycled on a regular basis, because it's really low mileage. So I knew there was something wrong with the battery. The codes that they sent me, basically, when you've, I've got some, can get some information about sort of detail of codes, and also some experience with the codes. Basically, there was two codes, one in the battery for kind of like cell deviation. It was like battery cells, but seemed to indicate deviation in the cell voltages. So this battery's got 90 approximately cells in the battery, individual lithium cells, all bolted together in a series string, blah, 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 blah. And yeah, some deviation within the cells, okay? And then also an ECU code for battery comms, which is quite common with this architecture, that when there's a battery problem, the battery will refuse to do certain things, and then the main ECU interprets that as lack of comms because it's saying start, and the battery's not doing anything basically because it's not happy about something. Okay, so I've seen a Zoe in a similar state years ago. I bought a quite high mileage Zoe 22, and it was really low on charge and wouldn't charge, and it basically the battery just got too low. And then it gone into this kind of like shutdown mode. And I did a reset on that battery. Well, I actually manually charged it with a high voltage power supply, which was exciting. And then did this battery reset and it came back to life and it was fine. And then that battery, I think, was a bit tired. And if you left it flat for too long, then it would go under what it was happy to charge at. So a bit of experience with these. So I said to Lucy and Christine, yeah, you know, I think it's worth getting the van here. We can have a crack at it. Renault said to them, it's going to cost too much to investigate. It's not worth it. You should scrap the van. It needs a new battery probably, and the battery's 20 grand. Basically, that was Renault's response. So when I jumped in the van, first of all, to do the diagnostics, I noticed that the diagnostic machine, basically, it gives you the voltage. It's not on there at the moment, but on the main scanning screen where you're waiting for the fault code to come up, it gives you the 12 volt battery voltage, just so you can kind of keep an eye on it. It's quite handy. And it was 14.45. And I sort of thought, okay, this van that won't start, it had electrical failure danger on the dash, which is kind of like a catch-all message. If there's something wrong with the drivetrain, that's what you get, basically. A bit like electric motor failure on a Zoe. So it had a danger message, wouldn't start, but yet the high voltage system is coming on. So I'm thinking, okay, interesting. And thinking about cell deviation, what are the kind of things that can cause that? So I've seen with other cars, cell deviation because you've just got weak, worn, tired cells because it's old, high mileage. So like Mievs, not very common EV, but Mitsubishi Miev. But you know, like a Nissan Leaf, you can get high deviation, especially at a low state of charge. This one I thought it had about a quarter, and they said it wasn't very low. They said that was the weird thing because Renault said to them, we had similar with a van that was up for sale at another garage or whatever, and they left it flat for too long and then the battery wouldn't charge, basically. So that's probably what happens. You've not used it enough. But they said this is strange because it wasn't left flat. That didn't happen, but yet the battery's got into this state. So I had a look at the codes. It was similar to what Renault said. Look through the battery data, and at that point, basically going through them, you can see we've got a deviation here, cell number 80. So when I first plugged them in, we were at about 385. So this is in millivolts. So we've got 3.9 volts in most cells. At the moment, we had 3.85, and this one was 3.45. So it's not out of its normal range, but it is dissimilar to the others. Now, because basically I carried out the battery reset procedure and just plugged it straight in before it had a chance to think about it, and then it's been charging for about 20 minutes, something like that. So that's good. I was hoping it wouldn't then just drop straight out with a similar code, which it hadn't done, which is cool. So we can see that this cell is performing what looks like normally the voltage is coming up. So we've still got 0.4 volt deviation, which is quite a lot. But if we think about this van, they don't use it that much because of really low mileage. They probably don't fully charge it a lot, and it will only balance charge when it's full. And you have to balance charge because lithium batteries really must operate within their certain voltage. And it will only do that balance charge when it's full. So when it gets to pretty much 100%, it turns on little bleed resistors, so a little bit of load onto the highest ones. So out of these, is this one the highest, and that one's bouncing up. So it will take the highest ones and drain them a little bit and let the others catch up. And basically all that is that the batteries perform slightly differently because they have a tiny little bit of manufacturing variance. They've got a resistance inside them. Batteries have an internal resistance, and that is a little bit different. So although it sounds weird that they're in series, so you've got the same charge current going into them, the same load on them, you'd think they would perform exactly the same. But they very slightly don't, and that's why you need balanced charging, and also because you can't overcharge a lithium cell. You have to treat it quite carefully. With old nickel metal hydride cells, and so like old Priuses and stuff like that, and even like your cordless phone at home, it's got 2 batteries in it, right? But it doesn't charge them separately. With that nickel metal hydride chemistry, you can overcharge them very slowly, and that's how your phone charges. Basically, it charges at like 100 milliamps forever, and the cells get a little bit warm, and that's them like bleeding out the current themselves. So they're doing their own little balance, and as long as you keep that controlled, it's got to be like 10% or less of the capacity of the cell or whatever. So if you got like, you got 1,000 milliamp hour cell, 100 milliamps is your max, and that's how those ones work. You can't do that with a lithium battery. It will just expand and things will get very exciting. So you have to closely balance them. So when I was sort of expecting this van, I was kind of thinking about what we might have, and I knew we were going to have a bit of deviation. We've either got a cell that's weak and is discharging itself, or we've just got manufacturing variance, and that variance hasn't been ironed out because of the low mileage. And I think and hope it is the latter. So the plan is to leave this on charge. We need to get this to the top so it balances. There's no procedures to run a manual balance or manual smoothing like there is on some other EVs. And as far as I'm aware, it will only balance when it gets full. So it will basically bleed down all the other cells. And how many has it got in this one exactly? It's got 96. There we go. Quite cool today as well. Yeah, so it will bleed the current from those others when it gets full. And what I have to say is the power of that balancing action is very, very slight. Okay, so when it gets to that top, it turns on those resistors, but they're just little resistors on a circuit board. They can't deal with a lot of heat. There's no heat sinks or stuff like that. So it is a really, really small amount versus a massive lithium cell, relatively. Okay. There was an interesting case with one of the MGs. I think it was the ZS EV, where there was an issue with the battery management software and the balancing action was poor. Basically, it wasn't powerful enough. So the battery would get more and more out of balance. So MG corrected this with a software update. So people were like, "Oh, my car's only charging. You know, I've plugged it in and it stopped charging, but it's only on 50% or 80% or whatever." But it's because you've got a low cell like this. So when the others are full and it's balanced as much as it can or as much as it's designed to do, you've still got variance, and that's what happened. So they released a battery management update. But then what our customers had to do was charge and discharge the car about 5 times or 10 times, something like that, to get that balancing action to happen enough times. So we need to as many times as possible, provided this van keeps charging, it doesn't sort of like go into the battery safety protection mode again, is get this to full, let it do its thing, do not unplug it, kind of thing, just to make sure that it is fully finished and done all the balancing it thinks it can do. Then we jump in the van, turn the heater on, get it down, get some charge out of it, and do it again. So we need to get that balancing going as many times as possible, and really hope we can get that cell to go up, basically. What will help us a bit is the charging voltage versus state of charge is not a straight line, it's a curve, it's a charging curve. So when the cell is getting towards flat, the voltage drops more, and when it's getting higher, there's not much change in voltage for a rising capacity, if that makes sense. So if you were going to draw a graph out, and if you've got, let's say, voltage up the left and then capacity along the bottom, the voltage at the start goes up really quickly. So if it was just like 50% voltage was 50% capacity, you just have a straight line through, wouldn't it, you know? And like at 25% capacity in the cell, 25% charge level, it was 25% of the voltage range, it'd just be a straight line, wouldn't it? But it's a curve like this, so a little bit of charge, it rises really quickly, and then it gets more towards full, that curve comes round, and at the top there's like, these voltages will hardly change, but you'll get quite a big change in capacity, basically relative to the change in voltage. So this should converge as it gets towards the top, which will help the van to be happy. But we need to really get that close. I mean, you can see what these other ones are like. We're talking like 2 millivolts here, and we're talking 400 here. So we have got a big difference. So very much not out of the woods, but I hope that this isn't a dying cell, and that it's just the way they use it, really low mileage and not a lot of balancing. So hopefully a lot of charging and then some advice on usage will keep this van going, but we will see. So it's good to see that it's not like really low. If this was like 2.8 or 3.1 or something, it'd just be too much. You'd know that you had a weak cell, and all cells vary. The good thing is that it's charging normally, so we're not seeing like a massive spike in that charge level. If that cell had gone really low capacity, that voltage would really rise really quickly. It's not, it's performing normally, which is good. It's just at a different charge level to the other cells in the battery, because it maybe is a tiny bit weaker, but as long as it can perform to a reasonable standard, and it looks okay at the moment, then we might be happy. And I suspect there are a lot of EVs with cells that have a little bit of self-discharge or are quite different, but people use them enough, balance charge them enough, and it's all okay. So I'm going to let this charge. It reckons it's on, oh, what's that, about 30%. There's an interesting stat actually, which we should take a look at, because this will help us to work out whether things are getting better, whether we're winning. I thought it was in here. So what I'm looking for is, there's one that tells us minimum cell charge and maximum cell charge, whether it's in EVC. Battery condition 97%. You love it. Right, voltages. Here we go. So 15.3 and 75.1. So basically, the cell with the most current charge in it is at 75%, and our one that's not feeling so good is at 15.4%. So what obviously we want to see is that gap get closer, and that's what we need, basically. So I always find it interesting in these states what it uses for that, because that it thinks is about a third. But yeah, one of the cells has only got 15% charge in it, which is kind of interesting, really. There are other EVs that I've worked on batteries, and they will always go off the lowest one. So you really see it if you've got a failing cell, that this will just start to go down because that one is self-discharging, or, you know, you fully charge it and then it sort of like stops at 80%. Sorry, I get the focus on my finger. Yeah, stops before it's full, that kind of thing, because of the low one. Renault seems to kind of average it out, but yeah, fun and games. So we just let that charge, because it should help the van to be happier when it's higher, because the voltages will converge, and then we see what happens. So yeah, we're currently it's about 60% different. Let's see if we can get that to come down. All right, see you in a bit. Cheers. Okay, sit rep. So we've been charging for about an hour. It's still charging, which is good. So that's the first thing. Charge amount is going up. If I move my hand, that will focus. So yeah, it thinks it's got more charge, which is good. And we'll have a look at the actual charge stats on the charger in a minute. So not a massive change on the lowest to highest, but we're not really expecting that because that's going to come when it gets full. So, but let's just, oh, that's at the bottom, isn't it? Oh, no, I've gone straight past. We're doing well now, aren't we? Right. And yeah, that's about the same, isn't it, really? We're not massively expecting that, but yeah, as it gets higher, they should converge a bit. But that kind of, yeah, it's still doing its thing. So we're not out of the woods, but yeah, there's certainly some hope there. So yeah, okay, right, I'm just going to go and have a look at the charger and just see what that's taken on. One moment, please. Okay, so hopefully you can see this and there's not too much flicker, but it's been charging for an hour and 2 minutes, so my supply voltage is a bit low at the moment, but so it's taking 9 amps, 2 kilowatts, and it's taken on 1.87 kilowatt hours. So yeah, that's reasonably positive. It's taken on quite a bit of juice, and it is charging basically. All we can kind of do really is let it charge and see what happens. Don't worry about this too much, that is quite low, but we'll have a bit of an issue with low supply voltage at the moment. But funnily enough, I use quite a lot of electricity. Weird, isn't it? But anyway, yeah, so we're just going to leave it, aren't we? It's really good that it's not stopped, so it's not kind of just gone into that protection mode again. And I'm just really hoping that cell's going to come up a bit when it balance charges, but all we can do is wait and see. So yeah, I will leave it for a bit more and we'll see what happens. All right, cheers. Okay, so the van's been charging just over 2 hours, about 2.25 hours, something like that. Still going, which is really good. Charge level's going up, so that is all good. Looking on the diagnostic machine, we're basically still there with our 0.4 variance, which is slightly annoying because you'd want it to come up, but is also kind of a good sign because you want it to perform the same as the other cells, and we're just hoping it just at this point in time happens to have a different charge level because it is slightly different. So yeah, it's kind of doing its thing really. I mean, yeah, maybe there's a bit, no, I don't think it's closer, is it? I think it's just the same. And then I suspect if we flick down and find the lowest and highest, yeah, it's about the same, about 60%. So that's cool. That is basically what we expect. We're just hoping that, you know, obviously once it comes to getting this balanced, we can do it at the top and it'll perform normally. But seems to be charging normally. Yeah, the voltage hasn't skied up, so yeah, not too bad. The other scenario that I realised once I finished recording earlier is I was at a garage a few years ago and they had a Nissan Leaf in, and that Leaf, basically the cells were just really out of balance. Some of them had got low and it was causing a problem. A little bit like this, although in that case it was a bit kind of worse, more variance effectively in terms of multiple cells, whereas this is just kind of like one really. Yeah, in that case the customer didn't have a home charger, they just purely public charged, so there was no balancing action at all, and then there was just a lot of variance throughout the pack, which I suspect, although these are quite closely balanced, yeah, I was going to say I suspect these would show a bit of variance if you see that you get the old data and then the updates. Yeah, it would show a bit of variance, but there's not a lot really. It is just that one. Bing. Yeah, so we will see really. We will see. Is this cell weak or is it just a little bit different? I mean, it may be the case that it's a little bit weak, but it's usable. But it's charging okay, isn't it? I mean, if you got that cell and tested it, you'd say it was all right. More than likely. Sort of bench tested it. Well, we will see. We'll keep going. I'm glad it's still charging. That is really cool. We'll see what happens at the top. and we'll go from there. Yeah, I mean, it's quite, we're going to have to bleed a lot of current out of this, this pack to get this one up to match the others. That's the thing, isn't it? Okay, well, I guess we see what it looks like after this charge. Yeah, there's really no other way of charging it other than taking it out, which I don't really want to do, but okay, well, we shall see. At least we got a chance. The other thing I've actually done, which is kind of useful, in the past when I had a similar scenario, in that case it was actually just the cell had like failed, but I was just trying to see if I could balance it out, is whilst it was charging, basically putting kind of load onto the car effectively. So I had like the lights on and the blower going and stuff, it basically just so that the current going into the battery was less. Yeah, because you effectively, the balancing power is a fixed amount, but what you can vary is the charge rate. So if you can charge it slower, then relatively that balancing power is higher and the balancing phase will last for longer effectively. So we'll see what it comes to. We'll do a few granny charges and see where we get to. All right, cheers. Okay, so I've been charging for about 4 hours. It's taken about 7.5 kilowatt hours so far, which obviously isn't a lot to go from low to high, but that's because it's kind of limited. The top is kind of limited by sort of the lowest state of charge, and then the bottom is kind of limited by the highest effectively. So yeah, it's still going, which is good. Obviously near full says 45 minutes. That's because the car knows it needs to balance. So obviously it's, you know, if it was really near full and it just needed a little bit, it wouldn't, you know, it shouldn't really take 45 minutes, but that's always an indication that the car wants a long time to charge, even though it's kind of nearly full. So if we look in the data, not a massive amounts happened really. It's closed a little bit, but not sort of a massive amount. If we find that low to high, so we've got 34.94. Yeah, so we're still at our sort of like 60% different, it reckons. So we shall see what happens. It doesn't give us indications of whether it's balancing, which yeah would be nice to see. Some cars do, they literally tell you for each cell whether the balancer is turned on or not, which would be kind of handy, but yeah, we don't get that. I was wondering if there's any other sort of useful information. You can see the mileage there, although it's in kilometres. The kilometre mileage shows you that traction battery condition is not all it's cracked up to be, really. So yeah, so it's saying 93% charged, which is interesting because obviously one of the cells is really low, but I guess that's where that comes from, it being 93%. But yeah, which is funny because obviously one of them's at 34%. So because all the cells are in series, the available energy from this car is only like a third of the pack, so not much good. So we've got 5 amps going into the battery now, basically. So that is our sort of 9 amps from the granny cable, but then obviously that's 9 amps at 240 volts AC, but we've got to turn that into DC, increase the voltage, all that kind of stuff, so you end up with 5 amps basically. The balance effect is nowhere near 5 amps. So this is probably an interesting moment actually to see if we can do anything to just slow that down a little bit, because this is like the perfect time, isn't it? So if I put the lights on, will they come on? Yes. Can I get the how do you get the main beams to stay on? I'll have a look at that. But if I see that traction battery current's gone down to 4 amps now with the lights on. Does the blower come on? Yeah, it does. Not had much of an impact. At least those lights have had a bit of an impact. I wonder what other loads we can put on. I mean, we could put some more 12-volt loads onto the car, but yeah, at least that slowed that down a little bit. I'll have a think about that. But we can also see what happens at the end of this charge. See if that difference comes together. So we know it's about, that is just a fraction under 60%, isn't that? That's like 59.8% difference. So we'll see what happens. I'll have a play with this and I'll catch you in a bit. Cheers. Okay, so I've been keeping an eye on this And I was just about to record this video, and then I just noticed the dash changed. It had a charge remaining dash. Whereas now it's gone to the range. Obviously it says 39 miles. That is very much indicative of the fact that we've got a bit of an issue, that one of the cells isn't fully charged. So the charge that the van is currently drawing is about 0.8 kilowatts, about 3 or 4 amps. And that equates to traction battery current of about 1 amp. Interesting, couple of the modules have warmed up. So it's 6 degrees inside the battery case and 6 degrees on lots of the modules, but then 9 degrees on these. So it probably hasn't warmed up much from the actual charging, or at least they would have all warmed up kind of in unison. Whereas that one's probably warmed up because it's balancing a little bit. And see, there is current still coming into the battery. So although there's no indication that any charge activity, other than the fact that we've got a plugged in light, there's no indication that anything is really happening with the charge. It is putting a little bit of current into the battery, which is interesting. So there's still been not a massive real change with these, which is a little bit disappointing to get to this point. But it is still doing something, which is kind of interesting. Because you can see there's a bit of current going into the battery. So yeah, interesting. Still traction battery condition 97%. Yeah, never mind, eh? If we just get to this one, see, we can still see this is like 0.4. Well, it's a little bit more than that actually out, isn't it? Because these have gone up. Oh no, it's still point. It's like point. It is. I'm right. It's like 0.5 now, isn't it? So that's a little bit concerning. But we kind of got to let it do its thing and see what happens, basically. I'm just going to leave it plugged in and see what happens. Maybe it does its balancing phase kind of now when it gets left plugged in. I don't know. We will see. Right, we'll let it do its thing and see what happens in a bit. But yeah, that was kind of about there. Maybe it's just the charging curve has a sort of flat spot in it. Interesting. We will see. Okay, see what happens in a bit. So the van just kind of definitely finished charging. So I mean, it showed that range and the sort of plugged in light, but it was still consuming about 3.5 amps from the charger, which is kind of weird because it didn't look like it was charging, but the onboard charger was drawing that current, and then there was about 1 amp going into the battery. Whether it was balancing, I'm not sure, but I've just started the van and just put the heater on, and you can kind of see there on the power meter that it's drawing a bit. I don't know if we turn that blur up, whether it'll draw a bit more, but that needle basically moves to the right because the heater is basically sucking a bit of power. And then we can see traction battery current -11, so that's doing that, on -9 or 14 there, it kind of moves around. So yeah, it's going to turn in the heater on and off, which is fine. So it says charge 97.2%, condition 97%, yeah, right. And I want to see the highest and lowest, but yeah, that's our one there. So we're still, I mean, we're like 0.5 out, aren't we? It's not really reduced. So whether it was balancing, I don't really know. It's hard to say. I mean, it should have been. Maybe it did, but it's not that noticeable. I don't know. But yeah, we can kind of only just run through the process and see what we can get to, really. So yeah, this is what we were looking at before. Yeah, this has potentially got marginally closer, but not a lot. But maybe that's the balance power. We shall see. We shall see. So yeah, we just need to leave this heater on for a bit, and then kind of see what happens. Really, it'll make sure the van's nice and dry inside anyway. But yeah, that just went down actually. Yeah, it's only consuming 1 amp. Where's that power going? Is it warm? Ah, put the blower on. It's not warm. The heater must be doing something. Let's have a look under the bonnet and we'll just double check what type of heater it's got. But I think it's got the rather inefficient wet loop type. One moment, please. Right, it's getting a little bit dark, but hopefully you can see. But yeah, it's got the inefficient wet loop type, where it's got this header tank for the heater, and then this is the one for the motor. Well, not for the motor, but for the powertrain. So it calls that PEC, and yeah, the onboard charger and stuff. Motor is there called via this. Yeah, so we can see all those pipes there, so some of those should start getting warm, and then there's a heater box just literally, you can't quite see under there. So I think it's getting a bit warm. Oh yeah, no, they're getting warm. They're getting warm, so that's working. But yeah, it's got to warm all these pipes, uninsulated pipes, all that header tank, all that kind of stuff. Cool, okay. Well, we'll see what happens. Get it drained down a bit, charge it up a bit, and then see what happens. I mean, yeah, are we going to have to take this battery out and literally manually charge it? But is that going to be the real, you know, is that going to be the real solution? I don't know, it's hard to tell. It's hard to tell. I think all we can do is see if this gets any better or worse and go from there, really. This is obviously cycling on and off just as it turns that heater on and off, so there's not really a lot of heat coming through yet, but those pipes were warm, so where that heat's going, who knows? Right, well, yeah, it's moved a tiny bit, that, hasn't it? But not much. Not much at all. We shall see. Right, cool. See what happens in a bit. Okay, sit rep. Basically, not a lot's happened, although quite a bit has. Basically, the heater wasn't working, which is really annoying. It drew a little bit of power to get warm, and I could feel the pipes under the bonnet were warm, the heater pipes, but the air coming out of the blowers was cold, which was a bit confusing because there was obviously air moving. But basically, there was an issue with the flap, and the actuator for the flap, which I've had to take all this off, is that white bit there, which you can see if we go around here. Has now got a screw in the end of it. Basically, that had broken off, so that yeah, that wire end was basically just moving in thin air, and that white plastic bit was just on the floor. But yes, I had to take the glove box out. Unfortunately, to take the glove box out, you have to take the end sort of one on there that's normally got like the child, you know, turn off the airbag switch on it. But you have to take that off, but you also have to take off the trim around the gear stick, and then you have to take off the trim around that whole center console. What a nightmare. Anyway, so I have now fixed the heating. Oh dear, just so I can drain the battery down. So but the interesting thing, although not a lot's happened, the interesting thing is that it now thinks it's got more miles, so it thinks it's got more power, even though obviously that has kind of gone down, and I've sort of used a bit of heating. I'm just going to turn that on low so I'm draining a bit. Hopefully it won't cause too much noise. So just looking at the stats, that would seem to say we've got further apart, although the range is now higher, albeit range isn't obviously a wonderful indication of what it thinks is actually inside the battery. So yeah, we've now got like constant traction battery current, because the heater is, instead of just heating up the pipes, actually, yeah, is actually heating up the the cab. So yes, I'll continue to monitor this. Yeah, so traction battery charge, I mean, that's its kind of averaged out figure, albeit where's the high and low? Was that down here? Yeah, so the lowest 30%, highest 92. So yeah, we're still just over 60% apart according to that. Well, all we can do is cycle this a few times, as we were planning before I worked out the heating had an issue. Yeah, and just kind of see what happens. It's just really fascinating that the van, having sat here, that the range has gone up. Normally that it goes down because you're not doing any miles. Obviously, I haven't driven anywhere, but I've consumed some electricity, so that's really bad in terms of efficiency. Obviously, using electricity and going nowhere is bad, clearly. So normally the range would go down, but it's gone up. It's like my efficiency's improved, which is weird, which is making me think that the van believes the battery's got better. But yeah, not really sure. Well, now that I can turn the heater on properly, we can carry on with doing the cycles. That was really annoying me, so I was just like, I've got to fix that. I've got to fix it. So yeah, we'll keep an eye on this, and yeah, we'll see what happens. All right, well, catch you in a bit. I just love that traction battery conditioner. It's just nonsense, isn't it? Absolute nonsense. Right, let's just whiz back to cell 80 so we can see where we are at the moment. Right, so yeah, 3.58 or 3.59 versus 3.5 versus a 4.05. Yeah. I don't think that's really come down. Anyway, right. Well, we'll see what happens. I can leave this consuming electricity. Now I'm going to whack this heater up. Lovely and warm now. Yeah, whack it up there. And then in a second, when those pipes cool down a bit, that will move. You can see that kilowatt meter. Sorry, but if I just do that, that's better. That will consume a junky amount in a moment once these pipes cool down and it decides to turn the heater on. What does it say on there? Hold on, caller. Oh yeah, it's using minus 16 amps. So, yeah, oh, it's gone down to 9. It was, oh yeah, 15, 14. Oh yeah, it's wiggling around. It's wiggling around. Right, I'm going to leave this going. And I'll... Woo! Apologies. I will catch you in a bit. Cheers. Okay, right, let's just turn this heater down. So I've charged it for the second time fully overnight, let it completely finish by itself, whatever it wants to do, hopefully balancing. And then I've just about half an hour or so turned it on, and then yeah, just put the heater on for a bit. So you can see that's dropped down a bit. It's getting very pessimistic about the range, so that was obviously not a good indication of whether anything's kind of good or bad. I think it's caught up with the fact that it's just sitting here now burning electricity. So the difference basically between sort of the Cell 80 and the others is pretty much what it was. Quite disappointing, really. It's really not, for whatever reason, balancing out. And maybe this is pointing to the actual issue. Maybe this battery is just not balancing. I don't know. It's really odd. So yeah, I've started sort of tracking a bit more closely where we're up to. So yesterday during the first drain, 434. When I'd charged it, sort of, and I checked it a little while ago, 501. That's about 450 at the moment. So this is like second drain. So it's not really changing a massive amount, which is not a good sign. We can see there we're just on 60% difference. So that difference may have reduced a tiny bit, but it's a struggle to know how to trust the stats other than voltage, because the traction battery condition is still 97%, which is obviously complete nonsense, because you can't use this battery. Well, it's not really usable at the moment. You get a limited range, and then it keeps throwing up a fault code for traction battery cells, which is not surprising. So yeah, I'm just going to continue with this charging and discharging and keep tracking it and see where we get to, really. Yeah, it's interesting. I don't know whether we're going to need to take the battery out and charge that cell, but is that cell, is it unhealthy? It seems to be sat. The weird thing is, it's sat with about the same difference throughout these charge cycles so far. Pardon me. I would expect to see that change, that difference come down. Obviously, I realised I haven't talked about what I'm sort of expecting or what I'd like to see. So generally with a high voltage battery, 100 millivolts, so 0.1 volts, is sort of your concern threshold. You want to be concerned above that. That's not under load. That's just kind of like when the battery's sitting there. They will diverge more, or they should do, when it's a low state of charge, but don't seem to on this battery, weirdly. But normally they would do. So, and that would tend to be in the situation where the capacity is low, because it's really running dry. When it gets low, the voltage is really crashing because it's totally flat, whereas the others are not flat. They're just getting down, if you see what I mean. So this one it's more like it's moving up and down normally, but it's lower than all the others. You've got all your batteries there, and this one's just down here, and they're all going up and down together, but so far not balancing out. So a little bit weird, but we'll keep going and see what happens. I don't know. I don't think there would be a battery management fault that would mean that this one's ended up lower. Very strange, anyway. Well, we'll carry on and see where we get to. Yeah, I may... Well, we can put... There's other things we can do if we can't... If this cell has failed, or if there's another failure within the battery and it's not managing it properly,
there are other things we can do. But yeah, it'd be a bit of a shame to put a battery in it on the basis of one cell. But anyway, I don't think I actually mentioned also that Renault said they should scrap this van. It wasn't even worth doing any investigation into it because the diagnosis would cost too much and a battery was 20 grand. So they charged them about something like 160 quid, I think, to basically pull the fault codes and tell them it's terminal. They said their fault finding just got to, it needs a new battery. Battery's too expensive. Which is a bit disappointing, but kind of standard Renault, really. But I mean, 20 grand and whatever. I mean, there's one cell. The problem is one battery cell within this big battery, one of the 96, isn't it, I think? And in any case, second-hand batteries are available, and these Kangoo batteries tend to be really reliable. There's no rapid charging, there's no cooling on it, but it doesn't need it. The maximum charge speed is 7 kilowatts. It is designed for deliveries, last mile delivery in a city. You charge it at night and use it during the day, and that's it. So it really shouldn't be stressing the battery. I think it's just the low usage that that's meant that this one has really dropped. Where are we? That's the trip meter. There you go. 9,287 miles. Kind of mad. So, well, I'm going to keep this, put this heater on, and then it did show me the kilowatt hours usage, which is quite cool. Oh, look at that. If we put the heater on, I presume that will show that. Much like it shows me the battery amps. Yeah, there you go. It's a plus, which is interesting because that's actually drain on the battery. Weird. Anyway, shows on the diagnostic machine as minus amps, which makes more sense because it's going out. Anyway, right, I'll leave this doing what it wants to do. And yeah, it is a 4 kilowatt heater, that electric PTC heater, wet PTC. So yeah, I'm going to leave this doing its thing. We'll do a couple more cycles. I'm going to write down my stats, and then yeah, see what happens. Right. Okay, so let's just turn that heater down. So this is the third repetition of charge and then drain. So we're on a kind of drain at the moment. I think I'm actually going to plug it in now because the lowest cell, when it adjusts, is 30%, which is our kind of bad one. So the difference there, you can see we got 59.7% because we got that 0.4 there instead of 0.1. So kind of in the 59s, but we're still nearly 60%. So yeah, I mean, I'm tracking this if you can read my terrible writing. But yeah, it's training downwards, not a vast amount. The millivolt difference is not actually, well, it's gone up and then down, and then that bit's it's about the same, isn't it? So when I'm draining, it's about 450 millivolts. When charging, it's about 500 millivolts. 500 millivolts is a lot. Half a volt. Half a volt self difference is a lot. So is this going to come good? I don't know. I really don't know. I think it is balancing, just very, very slowly. So I think I'm going to plug it in now because I just want to do these cycles as quick as possible, and then I can get another cycle in today. Because if I get this charged, then yeah, whether I'll get it drained and charged again tonight. But anyway, and I'll just do it as many times as I can, really. Yeah, so 30% on that one. Even the top cells have got about 10% that they can go into them. It normally does about 97, 98, doesn't it? I think so. Well, we shall see. At least it's nice and warm in here. But yeah, I was thinking about that flap actually. Had a chat with someone who used to do fleet sort of vehicles, EV stuff, and he said, "Oh yeah, that's really common that the that mixer flap breaks." And I sort of thought to myself, why does it need a flap to put the air through the heater matrix? Because it only turns on the heater. It's kind of like kettle in a box, basically, with that extra coolant thing that we showed you before. Why does it need to have a flap to go through there or not? Because that matrix only gets warm when you select hot anyway. But of course, it's from the diesel version, because obviously with the diesel version, that heater matrix is hot all the time because it's got coolant, engine coolant going through it. So when you put it on hot, you obviously want the air to go through the heater matrix, and when you put it on cold, you don't. So I guess one fix for these, because I've just kind of like screwed the end in as I showed you, but what I could actually do is just glue the flap, put it in the sort of position where it's the up position where the air is going through the heater matrix, glue the
actual flap actuator part. And then the end of the cable doesn't need to do anything, because when it's on cold, it won't turn on the boiler. So the air will be going through the heating matrix, but it doesn't matter. So I guess I'll, use it maybe, and just trying to think about something that'd be more reliable, assuming we get this car. Yeah, this van even back on the road. So, right, I think I'm going to plug this in again. Hopefully it won't take too long, and maybe get another drain done tonight. We shall see. Are we going to get there anytime soon? Interesting. Okay. It's obviously not self-discharging, is it? It doesn't appear to be. But how's it got so far out from the others? Not sure. Okay, right. Yeah, maybe it's got like a tiny self-discharge, because they all have a tiny bit. But they just never balance charge it. Don't know. Well, we shall see. Right, I'm going to plug it in, see what happens. Oh, one really annoying feature I worked out of this van. So the key doesn't have like a flap open. Or not flap open, because you just pull the flap open on these, but the stop charging, so to like do the little locking pin to pull out the type 2 cable. So because this is just a diesel key, obviously, so you just press unlock and it stops charging, which probably normally is okay, and then if you just leave it, it starts charging again. But for this vehicle, I do not want the charging to stop. I want it to carry on and balance. I don't want to interrupt it at all. And similarly, if you open the door, because I've been leaving it unlocked, so I don't have to press unlock, but then I opened the door earlier and it stopped the charging. It's just like so annoying. So, because I like to kind of jump in and have a look at the stats, basically, just now and again, as I'm kind of going by when I've got 2 secs. So, yeah, usually when I've got my cup of tea, and then now I think, I'll just go and check the van. But yeah, so now I've been leaving the door ajar. It's just like really annoying. But anyway, Kangoo features. So this charge, I'm just not going to interrupt it. I think I'll just leave it. Won't bother too much. I like to record the stats, so that's the annoying thing. I'll leave the door ajar. That sounds about that. Right, so I'm going to plug it in, door ajar, cycle 4. Yeah, cycle 4. And we'll see how we go. Right, cheers. Okay, so I've done a few more cycles in this van. Probably about 3 more. Put the heater on and then put it on charge, and it's just not bringing that cell closer. So if we have a look at the data, so I've been comparing 80 to 81 each time, and we can see that we are still just over 500 millivolts out, so 0.5, and we're about 0.9 and about 12 there. So yeah, 503 millivolts, something like that. So that's really odd. It's just not come back in. It's not got any worse, but it's not got any better. Then if we track the so I think this battery's nice, 4.7% charged. There we go. So this lowest cell to highest cell, so we're above 60% now. So that's like 62.3, I think, if my serves me correctly. So yeah, I got that down to 59.2 was the best, but I was shallow cycling it quite a bit, so I was just putting the heater on for sort of half an hour or something, just so I could then get it back on charge, and it wasn't having much of an impact. And I thought maybe I need to cycle it deeper, so I was kind of taking it down till this lower cell was about 10%. I don't want to push it too much and sort of completely get it so low that it wouldn't start. But yeah, it still just wasn't making a difference. So that basically has not worked. This is still odd because the cell acts like it's healthy, but it's at a completely different charge level. We don't know if it's related to the previous repair, but I've actually got a balance board here because I thought some people might like to see. So this is a circuit board. It's from a different car, but it kind of does the same thing. So this fits on a module of cells, and you've got these connections here which screw down onto the cells. So there's cells like kind of like this, if that makes sense. There's 4 there, and it's designed for an extra board here. This is like the comms connector, and then there's like another slave board which is a bit like this, but literally just with connections back to here. So this is monitoring the voltages and temperatures, and it's also balancing. Now if we look down onto these components, you see these here, these 620 resistors, so 62 ohms, so 62 and 0 zeros, no zeros, and that's actually the voltage monitoring chip, and they can fail on these boards. This is from a Mitsubishi IMEV or Citroen C0, Peugeot Ion, one of them. So basically you can sort of see there that these are kind of linked together. So this board monitors 8 cells, and we've obviously got 16 resistors here, so they work in pairs. So each cell has 2 of these. Literally, you'll be able to see this better than I can because of the HD and all that. So we get 2 of these for each cell. They're in parallel, so it's actually the resistance goes down. So when you do the maths, basically the power of the balancing on this, given the cell voltages, normal cell voltages, is about 100 milliamps. And you can kind of expect that because these little surface mounted resistors, they can't get that hot, you know, because they'll melt off the board. They haven't got any cooling or anything like that. But this is kind of how it's done, basically. So at some point, this chip is instructed to switch on these balance resistors and to put them across the cell effectively. And then they just get a trickle of current going through them. And that's kind of how it works, basically, in the actual mechanics. So yeah, it's kind of cool. It's monitoring everything. You get isolation on these boards as well because you've got effectively the 12 volt comms, 12 volt system sort of talking to the high voltage system. So it's got to measure voltages, but that got to be reported back. So for sort of there's isolation and all that kind of stuff on this board as well. I think there's an opto isolator or a CAN transceiver or something that does it on these, but yeah, can't remember. But yeah, that's how it kind of works in practice. So anyway, what we're going to do with this van, so the last thing I kind of want to test is to put some more load on it. So what I'm going to do is I'm going to drive it just down my lane because where I'm based is just off the road, which is kind of handy. So I can't go very fast because it's kind of a bumpy track, but I can put more load than the heater was putting on it and just see what happens to the voltage basically. So I'm just going to set this up. I can record the data on this machine and this diagnostic machine, and then basically we'll be able to go back through it and see what happens because obviously I need to drive rather than look at the diagnostic machine. So I'm just going to get this set up, and yeah, traction battery is still 97%. Yeah, good to see. Anyway, right, yeah, so I'm just going to get these voltages just so it's not tracking loads of data. If you get it to try and record tons and tons of data, sometimes it's just can't refresh it fast enough kind of thing. We can actually get these to tick. Yeah, so just kind of make sure we've got everything that's useful. Don't think there was too much at the top, was there? No, so we just kind of wanted, let's probably have a few cells, just so we've got a decent comparison. Let's get like the 2 above as well. Yeah, so we can limit the data that we're capturing, and then basically see what happens. Overall charge level may be useful just in case the voltage crashes, current, stuff like that. So yeah, I'm going to set this up, do a little drive, and then I'll be back in a mo to see what's happened. Right, catch you in a sec. Okay, so I didn't break down, so that's the good news. And I've got a reasonable amount. You can see the dash on the dash, the sort of current current kilowatts coming out of the battery. I love the fact it calls it current. But right. So this is what it was at the end, and it's quite cool because we can sort of whiz back. And what I want to, what I want to see is that voltage. So, yeah, I really want to see the difference. I wonder if that high and low cell. Okay, so we're basically looking for swings in the data which show us that cell's not acting correctly. So let's go back to the start. So we said we'd got just over 500 millivolts, haven't we? So we've got 505 there, and we got the traction battery current here. So I've obviously set off. So we've got minus 11 amps, probably. Oh yeah, there we got to 110 amps. There we go. So yeah, so that has gone down. As that they've both gone down, which you would expect. And then we've got, what's that? We've got a little bit more of a difference, but not a lot. That's the really, really odd thing about this van. So we've got 117 amps. These cells are in series, so they all get the same load. If you get an old weak cell in a car like a Nissan Leaf's got common for it because of the lack of cooling. I mean, these don't have cooling either, but they don't have rapid charging. So under load, the voltage will really crash. And that's because of basically what's called internal resistance. So a battery has a resistance. It's not a perfect energy source. So there's a limit to how much power it can provide. But a new lithium battery has a really low internal resistance. So it is a pretty good current source, although not perfect. But as cells get old, they become worse and worse current sources. So they might have capacity, but as soon as you try and get it out, it's like there's a resistor in line with the power. So the voltage just goes down. There's like a kind of current limit on that cell, effectively. So you've got a bucket full of water, but you've got to pour it out through a straw, effectively. So the pressure of the water goes down. So the current, you know, the sort of voltage goes down as the current goes up. But we've got 117 amps. Is that the highest I got it to? Yeah, I think so. I actually regened a little bit, which is quite cool as well at one point. So we got a bit more. I got to go quite quickly, and then I had to back off a little bit. Oh, there was a little bit of regen there, wasn't there? So let's find back where we were. So 117, cool. So here we are, what's that? It's over 500, isn't it? So 511. This is the odd thing. That cell is acting like it's healthy, but just at a completely different state of charge. And that's really weird. Really weird. And also weird that the van didn't seem to balance it out. Albeit, was it balancing as much as it could? But it's just not able to balance it at all. The way the voltages act, it's like it's the wrong way around. So normally with a lithium battery, because it has a charging curve, I might have explained this earlier, but I've been kind of working on another van and on and off this one. The voltages should come together when it's full and diverge when it's low, because of basically if something reaches effectively zero or very low remaining capacity, the voltage will go down quicker. So you'd expect the voltages to differ at low state of charge, and you generally look at, if you've got a weak cell, you look at it at a low state of charge, because that really shows it up with a, you know, an old EV pack or whatever, or a suffering EV pack. But this one, they're closer when it's lower. It's almost like that cell has more capacity, but is a completely different state of charge. The only thing I can think is that when Renault repaired this battery in the past, they've put a new cell or a new module in it or something. Let's say they put a new cell in it, so that cell is like perfect. It has more capacity than the existing ones, and they just didn't balance it. I don't know, or they balanced it a bit but not enough. It's weird. If it had high internal resistance and was a classic failing cell, you would expect under 117 amps of load that cell voltage to really crash. And you can see these have come down. Have we lost 100 millivolts? That's frame 16. So we're at about 4.1. And we're at 3.9. So yeah, we've not lost a lot there, but we've not lost a lot of that one either. It's acting like a healthy cell, but a completely different state of charge. So under regen as well, let's have a look at that. So we want to get that battery current, that we got it to 26 there. So we've got 500 millivolts, exactly, half a volt. So the difference in voltage is slightly more on this cell 80, the low cell, but it's not significant, is it? It's you know, it's a tiny amount. I think that was the max regen. We only got 13 amps. We had another bit of foot down there, but again, we're just over the 500 millivolts, aren't we? This is really weird. Really, really weird. And then we just kind of turned it around and then stopped. So, very strange. Very strange. I think realistically, so this battery was not fixed by cycling it. We couldn't bring it back in line. I think the internal resistance is okay, but I've ordered an internal resistance tester because I didn't have one previously. And I keep kind of meaning to get one, and now it's just the impetus to go and get one. So that'll be fun to play with that. But realistically, we've got to take the battery out of this van. We can test the cell's internal resistance, which will be really interesting, because we'll see if it's worse, which I don't think it's going to be. I think it's going to be similar. If it's significantly better, we know that Renault changed those cells, or changed that cell, and didn't balance it properly, potentially, and they don't use the van much, so it didn't balance, and we got out of balance. or maybe it is a bit worse and we do have a failing cell, but we could potentially take the battery out, test that cell. If the internal resistance is similar to the others, so it's not an unhealthy cell and it's not expanded or anything like that, so if health checks are good, we could charge that cell and then drive the van and see what happens, basically, and maybe it'll be able to keep it in balance if we get it close. We need to get it within 100 millivolts, ideally really close. I may order a new bench power supply just so I can set the voltage really closely. Usefully on this van, I can obviously drain or charge the pack as much as I like. Normally when you have a failed cell, the van is or car is dead and the other cells are at whatever the voltage they're at, and you've got to get the one you put in, the replacement cell, to that voltage, so then the car can maintain it from then on forwards with it being really close. But fortunately here we can get it wherever we like. It's obviously not good to leave the van at a full state of charge, so yeah, I'll drain it down a bit, but we've got to get the pack out. So yeah, I think this will be part 1. And I've got to do a Zoe rebuild next, so then I'll get this one back in, take the battery out. I'll have a chat with the customer as well, just see what their appetite for obviously working on this van is. Obviously going to be more work involved, but yeah, I can drive it, which is handy. So I can literally reverse it into my workshop because the pack is right at the back on these. We can have a look if you like. Let's go and have a nosy. Just don't look over here. Oh no, more Zoes. Yeah, oh, it's all wet. Now I've said I'll show you and it's filthy. Right, so yeah, hard to see from there because there's a wheel in the way. So under here, that's the battery isolator. So that yeah, light coloured, that is, you can see that going backwards under there. That is the battery basically. So it's only about, yeah, sort of there to there kind of thing. So yeah, I can reverse it onto some ramps, which will be cool, and basically drop the battery down and then probably just push the van out. Or put it, actually, if it's not backed in too far, then drop the battery onto a trolley and then just pull it backwards, because then the van will still be in the same place. Something like that anyway. One of those combinations, but yeah, it's not going to be fixed today. I'll have a chat with the customer. I can switch that off. I will drain it down actually in a minute, but I need to move a few things around. Yeah, okay. Well, it's not going to be done today, but the plot thickens. This will be really interesting. I mean, one of the options that the customer could go with is just to swap the pack for another used good one. That's an option. It's the boring option, isn't it, really? But anyway, we'll have to get this pack out so we can analyse that cell anyway. That's probably the way to do it. That's probably the suggestion to the customer, is that we get the pack out, look at the cell. If we think it's suitable to charge or whatever, you know, if we're concerned, another pack. If we think it's okay, then yeah, charge it up and see what happens. All right, cool. Hopefully that was interesting. Thank you for watching. Please do subscribe if you're not already subscribed. It really helps. And also have a look at the membership as well. Some sort of interesting videos for doing your own kind of EV maintenance. You can request new videos and stuff like that. So thank you, and I will catch you later. Cheers.